Hello everyone. Today we will learn the basics of gravitation. So gravity was discovered by Sir Isaac Newton. When he was sitting under the apple tree, he saw an apple fall on the surface of the earth. The question came to his mind that if the apple is falling on the earth, why doesn't the moon fall? So the quest began, and he gave us this concept of gravitation, in which he told us that what are the mathematics behind this gravity, how the gravity works. So let us discuss this topic. So he said the force of attraction by the virtue of the masses of the body is called gravitational force. So he said if there is mass m1 and there is another mass m2, this is the center of mass m1 and this is the center of mass m2. So he said when the masses are put at a distance of r, what is r? R is the distance between their center point, not on this surface and this surface. This is not distance between their center. R is the distance. Okay. So he said the force of attraction between the mass m1 and m2 r is directly proportional to m1. So greater the mass m1, greater will be the force. Second, he said force is directly proportional to the mass m2, greater the mass m2, greater will be the force. And third, he said force is inversely proportional to the square of the distance between them. Inverse square law. So greater the radius, greater the distance between them, lesser the force. So if the distance between them is twice, the force will be 1/4 because square sign is there. So if we combine all the equation, what we can say, force is directly proportional to m1 m2 upon r square. So there is a proportionality sign here. If we want to remove this proportionality, then the constant of proportionality has to come. So force is equal to g m1 m2 upon r square. So what is g? G is called the gravitational constant, which remains same throughout. In universe, this is constant, gravitational constant. Irrespective of anything, this will remain the same. So what is the value of g? This value of g was calculated by Sir Henry Cavendish in 1798 through his experiment. So the value comes 6.7 into 10 to the power minus 11 Newton meter square per kg square. So this unit, it seems a bit different, but how can it come? So put all the thing on the left side and g on the right side. So what will you get? Force r square m1 m2. So force is measured in Newton, distance is measured in meter, and square sign is there, so Newton meter square, and in denominator kg into kg is kg square, so Newton meter square per kg square. So I think it is clear how this unit came, and this value is calculated through an experiment. Okay, so as you can see, this value is really small. So what we can conclude about this is that if mass is 1 kg, m1 mass, m2 mass is also 1 kg, and the distance between the two masses, the center of the, if mass has this center and this center, the distance between the centers of the masses is 1 meter, then force attracting each other is 6.7 into 10 to the power minus 11 Newton, which is very small. So if we want to conclude this, we can say that law of gravitation is an attractive force. So first thing we can say, it's an attractive force. In magnetism, magnet can attract as well as repel, but gravity always attract. Second thing which we can say, that it is a central force. What does it mean? The force which is acting between them act from this line and this line, means force will not act like this, like this, like this, like this. The force will act between the line joining their center. So this is the line joining their center. The force will act only through this line. So it is a central force, very important. Third thing, irrespective of the medium. So the gravitational force attracting, so the gravitational force which is acting between the two is irrespective of the medium, whether you put put this system in a vacuum, inside the water, in air, the gravity, the attraction remains the same. So it is irrespective of the medium. The fourth thing, the force acting on the body 1 because of the body 2, I have represented in F12, and the force acting on the body 2, this is the mass 2, by the mass 1 is same and in opposite direction. So force 1 2 is equal to force 2 1, but the actions and reactions are equal and opposite because of the Newton's third law. So we put a negative sign here to indicate that it is in opposite direction. Both the forces are equal. Force acting on body 1 by the 2 and the force acting on body 2 by 1 is equal and opposite. Fifth thing which we can say, that when we apply this concept, when we apply this formula, we have to consider the body to be a point mass. Means the whole body, we don't want to consider it as a big body. We will say that all the weight of the body will shrink into this point, and all the weight of this body will shrink to this point. So we will treat them as point. We will not treat them as a big body. We will treat them as a point, and we will consider the mass of this point to be the mass of the object will be the mass of this point. Okay. So we will consider it as a point mass. And last but not the least, we can say it is significant. It is significant for heavy object. How much heavy? The size of the moon, the size of the earth, they are very heavy, extremely heavy. If we consider this kind of object which have a greater mass, then because of this 10 to the power minus 11 Newton meter square per kg square, this 10 to the power minus 11, this is an extremely small value. If we multiply any mass m1 and m2, if the masses are 10 to the power 3, 10 to the power 4 order, then always it will come in points. So this force, you can calculate it for the sake of calculation, but this force will not give you any significant result. So it is only significant for heavy objects. If the objects are extremely heavy, then you will get a significant force here. Okay. So this is how he has given the calculations, he has given the theory about the gravitation, and he concluded that yes, moon also fall on the surface of the earth, but it is falling in such a way that it is constantly just missing the earth's surface. Okay, it is just missing the earth's surface, and it seems like it is orbiting, but it is constantly falling on the earth. So I think you have understood the topic. Thank you.